this lecture we are going to discuss the implementation of a single linked list. Before we start the discussion, let me recap the things we discussed in previous lecture. In previous lecture we discussed the basic definition of linked list, we discussed the advantages of linked list over array, we discussed the various operations that can be performed on linked list like insertion, deletion, traversal, etc. We also discussed what are various types of linked list like singly linked list, doubly linked list, circular linked list, priority linked list, etc. Now in this class let me discuss the implementation. So before we write uh, the code for implementation, we have to decide what should be the structure of the node of the linked list. Structure of the node depends on many things. Say for example, how many data we are going to store in a single node, as well as how many pointer fields are required. Because it's a simple singly linked list, so there will be only single pointer field. And also let me take a very simple example in which we want to store a single data, so it will also contain a single data field. So that can be so the structure can be declared as struct node int num and struct node pointer ptr. Also we can create the allies for struct node, so that we are not going to use struct node again and again into our program. So here with the instruction type def struct node capital node, we have created allies for it. The next thing we have to decide are the variables. What kinds of variable we are going to use in this program and what are their data structure. So in this program we are going to use two types of variable, one of node type pointer variables and another of integer type variables. So we have declared three pointer variables of node type: head, first and temp. We have initialized first and temp as 0. This 0 indicates that when the linked list is empty, these two variables first and temp will contain 0 value, or we can say that is how we can identify whether the no linked list is empty or not. We also have used two integer variable, one count and one choice. We have initialized count is equal to 0. The count is going to be used for counting the number of nodes into the linked list. We are going to make this program interactive, that's why we have used another variable choice. We have initialized it 1. Till the value of choice is 1, it will continue to create the nodes. As soon as we provide a non-1 value, it will stop the creation and will move further. So here is the program how we can create a new node. We can see that the first is that while choice, that is while 1, it means it is true, it will enter inside the while loop and will create a node with this instruction head is equal to node star malloc size of node. So the newly created node's address will be stored into pointer variable head. So once we have created a new node, next thing we have to store the data into this node. So we have written the following two instructions, printf and scanf, for taking input from the user and storing them into the data field of head node. So next we have to check whether linked list is empty or it already contains some nodes. So if it is empty, as in the beginning we have that we have declared two variables first as well as temp and initialize it 0. So if first is 0, it means the linked list is empty. If first is not 0, it means it contains at least one node. So if first is not equal to 0, it means already it contains some nodes. In that case, the last node's address of the existing linked list is stored in temp variable. That is, temp is pointing to the last node of the linked list. So we have, in that case, we have to connect the newly created node with the last node of the existing linked list. For that purpose, we have written temp ptr is equal to head. Once we have connected the nodes, we move the pointer variable temp to the last node of the linked list, that is temp is equal to head. It means now temp is pointing to the newly connected node of the linked list. If linked list is empty, that is the node created by node star malloc size of node is the first node, in that case we have to point the first as well as temp variable will point to the node created. So for that we have written first is equal to temp is equal to head. So once we have created node and properly connected it with the existing linked list, or if it is first node, properly adjusted the variables first and temp, next we will ask from the user whether he is interested to create more nodes or not. If he is interested, he will give the input 1, and if he is not interested, he will provide input 0. So for example, again he gives input 1, it will go to the while loop and a new node will be created with the instruction head is equal to node star malloc size of node. Now again with the following instructions, we will link this newly created node with the existing linked list. So this process will continue till we give 0 as a choice. As soon as we give 0 as choice, it will come out of the while loop. So our creation is now complete. So in singly linked list, we know that last node's pointer field contains null value. So we have to explicitly make it null with instruction temp ptr is equal to 0. Now it's a proper linked list. So once we have created the linked list, next thing is that we want to display the contents of the linked list. So we are going to use the variable temp for traversing the linked list. So we have reset the temp variable to the first node of the linked list and have incremented one by one till this temp is going to contain a null value. So we have written while temp is not equal to 0 and printed the data present into the node and also incremented the value of count, which was initialized 0 in the beginning, and moved the variable temp to the next node. So this will continue till temp is going to point a null variable or 0, we can say. So in this way it will traverse the entire linked list and will display the data. Finally, we are also interested to display the number of nodes present into the linked list. So we have written printf number of nodes in the list percentage d count, because count is going to contain the number of nodes created. I hope you all would have understood the creation of linked list, or we can say implementation of the linked list and its a traversal.